Hi all, welcome to Clear and Concise. Let's have a look at this question. For a random variable x with mean mu and an unbiased estimator of its mean x bar, which of the following statement is false? First, let's understand what does it mean by unbiased estimator of its mean. An estimator phi is called unbiased estimator of the parameter theta if expectation of estimator phi is equals to the parameter itself. That is, here in this case, unbiased estimator is x bar, so expectation of x bar is equals to, it is unbiased estimator for its mean, so expectation of x bar is equals to mu, that is mean, that is equals to expectation of x. So for an estimator x bar to be called as unbiased estimator, its expectation should be equals to the parameter itself. Here the parameter is mean, that is expectation of x. So the option D, that is expectation of x bar is equals to expectation of x, is true. It is true. Now let's look at other three options. All are related to variance of the random variable x. Now let's understand what is mean by variance of a random variable. Variance is the mean of square differences of x from its mean. That is, first calculate the mean of the random variable, that is expectation of random variable, which is equals to mu. Then find the difference between random variable to its mean, that is x minus mu. This is the difference. Next one is square the difference, that is x minus mu whole square. Then find the mean of this. So fourth step is variance equals to, variance of x equals to expectation of the above equation, that is x minus mu whole square. This is the definition of variance. Variance is the mean of square differences of random variable x from its mean expectation of x, or mu, from its mean mu. Just now we have seen variance of x is equals to expectation of x minus mu whole square. Now expand x minus mu whole square by using a minus b whole square formula. Then we will have expectation of x square plus mu square minus 2x mu. We know expectation of x plus y plus z equals to expectation of x plus expectation of y plus expectation of z for random variables x, y, z. By using this formula, the above equation can be written as expectation of x square plus expectation of mu square minus expectation of 2x mu. Here mu is constant and 2 mu is also constant. We know expectation of any constant is equals to constant itself. By using this formula, the above equation can be written as expectation of x square plus expectation of constant is constant itself, that is mu square, minus 2 mu is constant, so we can take it out, 2 mu times expectation of x, that is equals to expectation of x square plus mu square minus expectation of x is equals to mu, expectation of x is equals to mu, so 2 mu times mu, 2 mu square, which is equals to expectation of x square minus mu square minus 2 mu square is equals to minus mu square. So that is equals to expectation of x square minus mu is equals to expectation of x, that is expectation of x square, mu square, that is expectation of x whole square. So which is equals to first option, variance of x equals to expectation of x square minus expectation of x whole square. So these two statements, that is statement A and B, are equivalent statements. Now let's look at statement 3, that is variance of x is equals to expectation of x minus x bar whole square. Now again expand it by using a minus b whole square. We will have expectation of x square minus 2x x bar plus x bar square, which that can be written as expectation of x square minus 2 times expectation of x into x bar plus expectation of x bar square. Now let's assume x and x bar are independent random variables, so for independent random variables, expectation of x times x bar is equals to expectation of x times expectation of x bar, that is equals to, by using option D, that is expectation of x bar is equals to expectation of x, we can rewrite this as expectation of x whole square, that is equals to expectation of x bar whole square. Both are same, so let's substitute this in above equation. Then we will have expectation of, in this equation we are substituting in this equation, expectation of x square minus 2 times expectation of x times x bar, so which can be written as either of this one. So expectation of x whole square plus expectation of x bar square. Now we can write this as expectation of x square minus expectation of x whole square plus, we are using only one expectation of x whole square, one more is remained here. Now expectation of x bar square minus expectation of x bar whole square, because here we have seen expectation of x bar whole square is equals to expectation of x whole square. So here we can split like this. This is same as variance of x and this one is same as variance of x bar. So option C is the false statement. It is not equals to variance of x. So the correct answer is for this question is option C, because the third statement is false statement.